Okay, hello guys, welcome to this video of the Noa Hybrid Explained. You guys might have seen the introduction. We have been quite busy delivering the first units already out there, but now it's finally time to get the real explained video out there. We're going to show you all the ins and outs of the system, as well a government version we made as a commercial version. We obviously had to overcome a couple technical challenges. The first thing which might comes up into your mind is the vibrations of the two-stroke engine we use to generate power. Basically, we ended up with a very strong frame which is wire damped in wire dampers, and we can control on each point of the center frame where we need to cancel out a certain frequency. So the flight computer which we use does not even recognize that there's an that there is a combustion engine vibrating on top of the center core frame. So the flight computer thinks it's just an electric drone and flies amazingly stable. No vibrations, also no vibrations all the way down to the payload. So to go back a bit to what the hybrid system actually does, it basically generates electricity created from a two-stroke boxer combustion engine, and we pump that energy into the electric drone. So the electric version of the Noa is basically the same as the basics of the Noa Hybrid. The only thing is we just completely redesigned the whole power unit on top. Where normally the battery is placed, we now have a two-stroke engine creating this energy, with the obviously advantage that we now can fly for hours instead of minutes, which is the biggest thing compared to an electric version, where batteries don't get lighter. This drone gets lighter during its flight, and the drone becomes more efficient, and therefore we can actually then fly longer. The engine is a liquid-cooled engine, where most of our competitors using a air-cooled engine, but the liquid-cooled engine is just so much more stable in terms of different environments where it needs to fly in. Here you can very clearly see we have a large radiator in front, which is there for cooling the liquid for the liquid-cooled engine. A very unique thing we have done is also have an external tube built up on the backside of it, where if the drone hovers, for example, and stays still and doesn't have airflow getting through the front of the grill of the drone, these fans will actually go on by it's basically a forged cooling, so that they will keep and control the engine at a very stable temperature. As we all know, in the car industry there's almost no air-cooled engines anymore. Just the water-cooled engines are just so much more stable. They keep the cylinder heads at a stable temperature. We can control maintenance at a much more secure level, and therefore, yeah, we also have made the choice to actually go with a liquid engine. We have a very large variance of users in different industries, from different temperatures to different air pressures. We choose the option of going with a fuel injection. So on the middle or the inside of for the hybrid engine, we use a fuel injection system. It's way better to control. We don't have to adjust anything. It basically adjusts the fuel to air ratio by itself while recognizing different air pressures and different temperatures. The exhaust we use at this moment is a completely customized exhaust made by a performance exhaust company we teamed up with, as there was nothing in this market which could basically achieve our needs. Let's say it's a very customized titanium sheet metal piece with a lot of knowledge in there for tuning this exhaust at this perfect RPM where we're running on. It's very lightweight, very durable, and it's just the best fit on this specific engine, let's say. The batteries on the system are there as a backup. Obviously we use the batteries to start the engine, so it's a self-starting engine, no extra tools needed for that. And then the batteries will help eventually when flying in, let's say, harsh environments where the drone really needs to fight against wind also. So these peaks and gusts, those will be picked up by the backup batteries, and then the combustion engine can run at a very stable, efficient RPM, and the energy while flying in an efficient mode the backup batteries will be recharged again while flying. From the standard version GPS system on this drone is already a dual GPS antenna, What it does basically is it helps the heading correction, so it doesn't use a compass, which is quite sensitive for magnetic interference, but it will just use a GPS also to get the heading right for flying forward or flying these straight missions. We have a mil-spec GPS and a mil-spec dual GPS with anti-spoofing, anti-jamming algorithms in there. If, for example, you will have interference with a 1.6 gigahertz link, it can then actually identify that it has been jammed, and it will just go above or below that range to search for at least 9 to 12 or 13, 14 satellites to still have a stable GPS home point. All these instruments and all, let's say, payload sensors are all going into our flight computer, which we still use the Cube for. Super reliable, large track record, and we can tune that perfectly to our needs also, where we can now also have the live telemetry of the combustion engine, as well of any other components which are needed to show on the ground, transmitted through that process. We obviously have a government payload range and as well a commercial payload range. On the commercial side, yeah, we see the more like the Sony cameras, the phase ones, the LiDAR from RIEGL, YellowScan, and you probably know them already from the electric version. They all also fit under the hybrid version, and on the more government side applications we use the NextVision, Raptors, the Trillium, medium wave IR sensors, as well also the RIEGLs obviously, but we again have a large payload range with that. We use the same quick release system as on the electric Noa as on the Zoes, so your payload basically is super flexible by swapping them out. The complete range of the payloads in terms of kilos is all the way from 0 up to 6 kg payload, so it's quite a big range if it comes to what you are able to lift. It's nice to know that with the 6 kg you're still capable of flying at least 2 hours. So this is definitely the minimum amount of flight time you get. All the way from 2 hours, it will all the way go up to about 4 hours, depending obviously on your fuel capacity you're taking with. Also, what we see our competitors have one fixed fuel tank size. We are actually very flexible with this. So we can change the fuel size as well, the backup battery size, depending on what payload you're going to fly and also what mission you're going to fly. Because there are certain missions where you want to take off electric first for a longer time of period and then switch over to hybrid. Or you can just take off hybrid directly, and then, for example, you will probably need a bigger fuel tank from the beginning on. But we're very flexible on that. Again, as well, the payload weight changes. You can then automatically change your fuel to backup battery weight ratio. So we're outside now. We are going to fly the Noa Hybrid. We're going to showcase you how to build up the drone, how to refuel the drone, how to mount your payload, how quick and easy it is to get this thing up in the air. With just very little practice, you will be able to do this by yourself even. So yeah, let's build up this thing. So we just popped in the landing gear, easy and quick and go with a quick release as well. All the booms are also having a quick release, as well the propellers. So it's basically just plug in the connector, locking it with the quick release, so no tools needed to assemble this whole system. So let's pop up the first boom. So as you have seen, we built it up within 2 minutes. Next thing we're going to do is we're going to fuel up the drone with the automatic fuel station. It has the same, we're using the same type of battery we use within the extra extended batteries for the George, Signaf, all our control stations. There's one plug on the drone. We can fill both tanks at the same time. So let's show you. So we're putting in this battery in the front, all the way down here. Then we have a quick release, which pops into the fuel inlet. There you go. Wait for the click. There's it. And then it's just basically turning it on and filling it up. There we go. So once it's full, there's a digital display on top of the fuel station. As well, we have indicators on the side of each tank, which shows you the level. And there we have like the double check. There's an overflow as well. We use a drip mat so we don't spoil anything in our nature. So when it's full, you can even indicate it again by the visual sides of the tanks, or yeah, you will see it once it comes out. The fuel we can use within the system is pump fuel, regular pump fuel from 95 all the way up to 102 octane. But it handles also all the race fuels if you want to have like a longer lifetime of your pistons. But it accepts the quite normal pump fuel with just a little bit of two-stroke oil on top of it. As we do have different tank options, the quick release and interchangeable, quite easy. So you would be able to actually fly a mission while the drone is still in the air, have an extra set of tanks, make sure they're already filled up, drone comes back, you click in the new set of tanks which are already filled up, click in your fuel connector, the backup battery which is located on top of the tank, plug that in and you're good to go again. So basically it's just the fuel connector on the front which you take off, and then two quick releases on the side, pop, your tank comes off, and there you just from that same thing you pop it on like that, locked, and then basically you just plug in the batteries and fuel connector, and then we're good to go. There you go. And the system starts up. So we do have a couple of controller options. The first unit, the commercial unit, is a Heerling based system within our George housing. We do use a tablet extra on it so we can hotspot more information to the secondary screen. For now we do have the whole motor management in there, which I'm going through a bit later. Then a nice feature, we have the cup holder next to it for coffee during the longer missions obviously. And these things are also possible to actually take off. So if you have put it on a tripod, you can actually take off the holders where you normally mount them onto your harness. And then you just pop them back on and just twist them, lock them. On the back of it, you can see with the V-Lock battery system. So this one just pops in from here, and with this you basically can just extra charge the internal battery of the Heerling itself, where we now can extend basically battery lifetime unlimited. So while you pop this in, it automatically starts, there you are, it starts automatically to charge the battery. The screen also is with a quick release, so you can take off the double extra screen if you want. It's a very neat and clean system, and very flexible in terms of tablets and extra external accessories around it. We do have the Signaf UXV based control system. This is for the government applications where we can change and swap between a lot of different frequencies radio links. It standard comes on the back with an integrated Doodle Lab control link, but this can also be equipped with the Silvus radios, Kongsberg, MPU5 from Persistent Systems. So it's also very diverse. It's the more, let's say, government frequencies you can then also transmit on. Also, this one has an extra external battery we can put on the back to extend the lifetime, especially needed with the hybrid system where we fly such for a long time, where you don't want to run out of your ground station batteries. So we're basically ready to take off. First we're going to start the engine. It's basically just a press on the button. So I'm going to do that now. So engine runs. As you can hear now, I will stop talking now, but you can hear the noise level of this hybrid is really low. Turning the engine off is the same thing, just a press on the button. We're gonna just warm it up a bit more now to operation temperature. It's about 70, 65, 70 degrees Celsius. Then we're just gonna bring it up in the air, fly it a bit, and you can see what the noise level will be then as well, because it's obviously a frequently asked question. And then we're just gonna make some turns and show you how actually maneuverable this whole system is. So right now the exhaust is facing us. It will be even less loud when I face it the other way. So I'm gonna just yaw at 360 degrees. So I yaw at the drone 180 degrees. Basically what we have on our screen in front of us is the complete telemetry of the engine. We have flight time, battery voltage, battery current, so we know exactly how much it is actually using of the backup battery, fuel consumption used, the power, what we generate from the engine, engine temperature, fuel flow, RPM, and basically the stable voltage which comes out of the hybrid engine onto the drone. Everything looks super stable. We can set alarms to certain levels, so as an end user you don't really have to worry about these numbers while you're doing your inspection or flying your mission. You basically can just wait for these pop-ups if there's something going on. In, let's say, a worst case scenario, you would always have your backup batteries there, so if anything happens with the combustion engine, it will always be able to land safely on the ground as it switchovers to completely electric. A cool thing what we can do with the hybrid is for certain operations we are able to actually take off fully electric, don't start the hybrid engine at all, so we're very quiet and silent. Fly to wherever you want to fly to. Obviously you don't have the flight time what you will have with a normal electric Noa, but you still are able to, let's say, get a certain distance, fly that electric, silent, then switch on the engine while you're in the air. I'm going to demonstrate that now. So I'm just going to arm the drone without the combustion engine on. So I'm basically taking off. I will just hover for a bit and then switch on the engine. So basically now we're just fully electric. It hovers fully electric. And I'm gonna switch on the backup battery now. Sorry, the combustion engine. There we go. And now it starts to Guys, thanks for watching. I hope we explained you most of the features which will probably be questions in the first place, which we hope we have answered all these questions. If you have more questions, please contact our sales team. We're happy to answer you. We're happy to provide a demo. We'll fly this beast. And for sure, keep watching. We will probably send out more features, more upgrades on this machine soon. Yeah, please follow us, keep watching, and see you later.